Welcome students. In this lecture, we will continue with finding Fourier coefficients a0, an, bn. Now for the function f of x is equal to e raised to x. Okay, in the interval minus pi to pi. To find out a0, an and bn, we recall these two formulae. Integration of e raised to ax multiplied by sine bx, then this indefinite integral can be evaluated by using this formula e raised to ax, where a means coefficients of x in e raised to ax, okay, divided by a square plus b square. Now b is coefficient of x in sine bx, okay, into inside bracket multiplied by a, always first a then second b, a b, as इंटिग्रल contains साइन, इंटिग्रेशनच्या आतमध्ये साइनची टर्म असेल, देन फर्स्ट साइन, so a into sin bx minus for sine function negative sign, you have to remember this, minus b into cos bx. Okay, now if in place of sin bx in problem, if there is cos bx, then the only change is, as integral contains cos, a multiplied by cos bx and middle sign is plus, then b multiplied by sin bx. Obviously for a multiply one of sin or cos, and for b multiply by other. ओके, साइन किंवा कॉस असेल तर a ला साइन किंवा कॉस पैकी एक कोणतरी मल्टिप्लाय करेल, जो इंटिग्रेशन मध्ये असेल तो, अर्थातच मग b साठी तो सोडून दुसरा जो असेल तो, ऑब्वियस साइन आणि कॉस दोन असेल आपल्यासाठी. ओके, so these are the formulae. Now let us go for a0 first. You know that a0 is given by the formula 1 upon pi, interval is my minus pi to pi, so integration from minus pi to pi, and given function. Let us substitute the value of given function. It will become integration from minus pi to pi e raised to x. Now this is very simple integration. Integration of e raised to x is e raised to x, so we have to only substitute upper and lower limit. Now let us do it. 1 upon pi as it is. First put upper limit e raised to x, put x is equal to upper limit pi, upper minus, now lower limit. In e raised to x, replace x by lower limit minus pi. Okay, so this is the value for a0. Now we also recall the formula e raised to theta minus e raised to minus theta upon 2. This is actually definition of sine hyperbolic theta. From this I can write e raised to theta minus e raised to minus theta. Let us multiply both sides by 2, this 2 get cancelled, and here we get 2 times sine hyperbolic theta. So e raised to theta minus e raised to minus theta is equal to twice sine hyperbolic theta. Now you can observe that in this bracket e raised to theta, that is theta is equal to pi. So from the definition of sine hyperbolic function, this bracketed quantity is 2 times sine hyperbolic. Now theta is equal to pi. So you can keep both values. You can either take a0 is equal to this much, 1 upon pi inside bracket e raised to pi minus e raised to pi, or you can also take a0 is equal to 1 upon pi into 2, that I can write 2 upon pi into sine hyperbolic pi. Okay, both values are admissible. For multiple choice question, you will get either this or this, only one of them as option. The remaining options will be obviously incorrect. Now let us go for an. According to definition, an is equal to integration minus pi to pi f of x into cos of mx, and function f of x is again e raised to x integration minus pi to pi, function f of x is e raised to x into cos nx. Okay, now to evaluate this integral e raised to x multiplied by cos nx, we use the above stated formulae. From this we use first formula for cos. Simple idea, e raised to ax upon a square plus b square, a into plus b into, for cos remember this middle positive side. Okay, and values of a and b can be obtained from, value of a can be obtained from e raised to x term, and value of b can be obtained from cosine term. Okay, so I can see that here e raised to only x means coefficient of x is 1, so a is equal to 1, and from cos term coefficient of x is equal to n, so value of b is equal to n. So let us replace in our formula, a is equal to 1 and b is equal to n. Okay, so formula for integration is e raised to ax, a is equal to 1, so e raised to 1x upon a square, 1 square, 1 square is 1, plus b, b is equal to n square into a, that is 1. Integrand contains cosine term, so cosine first, cos nx. For cos, middle sign is plus, positive. B into, now b is equal to n, so n into, cos term is over, so obviously here we have to take sine term, sine nx. This is it. Now we have to apply lower and upper limit. Well, let me do it. Okay, this is our value of an. Now let us substitute lower limit and then upper limit. So let us keep this 1 upon pi outside. For upper limit I will provide separate bracket. Let us put x is equal to upper limit pi. In place of x replace pi. E raised to x becomes e raised to pi. Denominator 1 plus n square, we can write it as n square plus 1. 1 into cos nx, replace x by pi, so we will get cos n pi, but cos n pi is minus 1 raised to n, so 1 into minus 1 raised to n. And when we put x is equal to pi in the second term, sin n pi, but sin n pi is 0, that's why second term becomes 0 for upper limit. This is the value corresponding to upper limit. Upper limit minus, now go for lower limit. Now replace x by minus pi. So you will get e raised to minus pi upon again 1 plus n square. We can write it as n square plus 1. Again for cosine, cosine of negative theta, negative angle is same as cosine of theta, that is cos of minus theta is equal to cos theta only. So neglect that minus sign for cosine. So cos n minus pi is same as cos n pi, and cos n pi is minus 1 raised to n. And again in second term, sin n pi is 0, negative of that, which is again 0. So again second term is sin n pi 0. Sin of minus theta is minus sin theta. So sin of negative n pi is minus of sin n pi, but it is again anyhow all the way it is 0. Okay. So let us simplify this. You can see that minus 1 raised to n and this denominator term n square plus 1, they are common. So just we have to simplify the signs. Let us take minus 1 raised to n upon n square plus 1, a common factor, common. Then obviously we will be left with, in this first term, take out minus 1 raised to n and n square plus 1. You are left with e raised to pi alone. Second term is negative, so minus, and in this term we will be left with e raised to minus pi. So this is the simplification. Now again, either you keep this value as a value for an, or one may also simplify like this. If in answers of a MCQ question this is not the answer for an, then one can also write like this: minus 1 raised to n, many times written as cos n pi, because you know that actually cos n pi is minus 1 raised to n. We write it back as cos n pi. Okay, this is one possibility. Denominator n square plus 1 as it is, and as usual this bracket similar to a naught, we again write value for this bracket. E raised to theta minus e raised to minus theta is 2 times sine hyperbolic theta. Now theta is pi. Theta is pi. So just you can write in proper manner. Constant first, 2 upon pi, then remaining terms containing n. Denominator n square plus 1, and at numerator cos n pi multiplied by sine hyperbolic pi. This is the required value for an. As e raised to x is neither even function nor odd function, by replacing x by minus x, function changes totally. E raised to x becomes e raised to minus x, and you cannot write e raised to minus x is equal to minus e raised to x. This is wrong. So obviously e raised to x changes when we replace x by minus x. So it is neither odd nor even, and that's why you cannot say that bn is 0 or a naught an is 0. You have to calculate all the three Fourier coefficients. So final Fourier coefficient bn given by the formula integration minus pi to pi. I directly put up a value for function f of x is e raised to x, and for bn we multiply it by sin nx. Again I will use formula for sine. Okay, so middle sign is minus, first sine appears and then cos. Okay, let us use this, and again a is equal to 1, b is equal to n. A means coefficient of x in e raised to x term. So here coefficient is 1, so a is equal to 1, and b means coefficient of x in sine term. So here b is equal to n. Okay, so let us again apply the formula for e raised to x sin x. 1 upon pi, formula is e raised to x, because a is equal to 1 now, a square, a is 1, b square, b is n, a is 1, integrand contain sine term, so first sine nx first, and then cos nx. Okay, a into sine nx. For sine middle sign is negative minus b into b is equal to n. This is it. Now let us put upper and lower limit. 1 upon pi. When we put upper limit x is equal to pi, you will get e raised to pi upon 1 plus n square, that I will write n square plus 1. When we put x is equal to pi, sin n pi is 0, so no need to write 0, minus n times cos n pi. Cos n pi is minus 1 raised to n, or otherwise you can keep cos n pi as it is. Okay, this is for upper limit. I will keep a more bigger bracket for this. This is upper limit minus, now lower limit. For negative pi, just neglect that minus sign, because when cosine appears, cosine of negative pi is same as cos of pi plus pi, positive, and for sine it becomes 0, so the negative sign will not harm you, so it is so innocent. Now let us put x is equal to lower limit. X is equal to minus pi upon again 1 plus n square multiplied by, when you put minus pi in this, sine of n pi is 0, so again 0, I will not write 0, minus n into, and cos of n pi is again minus 1 raised to n. Negative sign will not change the value of cos. Cos minus theta is equal to cos theta. So again you observe that minus n minus 1 raised to n, denominator n square plus 1, again they are common. So let us again take common outside and simplify the remaining part. Minus n minus 1 raised to n upon n square plus 1, and when you take this common, again we get inside bracket e raised to pi minus e raised to minus pi. You can take this as your answer for Bn, or you can also simplify like this, 1 upon pi. If you want to keep this as an answer, we will just do a small change. This minus sign means 1 minus 1. This minus 1 and this minus 1 raised to n, you can write like this, minus 1 into minus 1 raised to n. Base is same, so obviously sum of indices n plus 1 upon n square plus 1 as it is, and again I will keep for this time e raised to pi minus e raised to minus pi as it is. This is one way to write your answer. Or from same Bn, you can again simplify Bn like this, 1 over pi. Now this minus sign as it is, minus n, and we replace minus 1 raised to n by its original value cos n pi as it is, upon n square plus 1, and as you know, this bracket e raised to pi minus e raised to minus pi is 2 times sine hyperbolic pi. Now this part is familiar to you. Okay, just we write the terms in proper way. Negative sign, then this constant 2, 1 upon pi, so it becomes minus 2 by pi, and remaining terms are n into cos n pi into sine hyperbolic pi and denominator. Yes, this is the value for Bn. So little bit difficult, but once you know the formulae for indefinite integral, this becomes very easy. Okay.